we are going to look at the concept of number systems. So first of all, let's understand what number systems even mean. A number system is a framework or a way of representing numbers with digits or symbols here. And I'm sure you've heard of a lot of different number systems. For an example is base 10, base 2, base 3, base 4, base 8, and um, base 16. Some of these number systems have specific names. So for example, the number system in base 10 is called decimal. And that's the number system we are all familiar with. That's what we use in our everyday activities. And I'm sure you've also heard of binary, that's base 2, and octal, that's base 8. And then there's also hexadecimal, that's base 16 that I mentioned. Okay, so how do number systems work? So first of all, let's look at the number system we are all familiar with, base 10. In base 10, there are 10 digits. These are those 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the 10 digits that are present in decimal or base 10. Each of these 10 digits represents a place value of a number in base 10. For example, let's look at the decimal number 27. Yeah. So this number 27, it's in base 10. I'm going to put the subscript here to show that. So this is the ones digits, and this is the tens digits. And each of these digits are represented by the digits that are found in the decimal number system or base 10. Okay, so if you want to go above a number here, and mind you, these numbers, they represent magnitude as well. So in the decimal number system, 0 has a lower magnitude than 1, and 1 has a lower magnitude than 2. So this is increasing magnitude. Okay, so this number that I gave here, this number 27, is obviously bigger than number 9, right? So how then do we get numbers that are bigger than the primary digits in the decimal number system? So if you look at the highest number, the highest digits in the number system, it's 9. This is the ones value. And it looks like there's no tens value, but then there actually is, there's a 0 here. If you put a 0 in front of a number, a whole number, it doesn't change the value of it. So you can see that there are an infinite number of zeros in front of this number 9 here. But it's not really necessary to bring it. That's why we don't really write it mostly. So if you want to go above this, the rule of thumb is that you increase the magnitude of the higher order digits. The higher order digits being the tens digits in this case. And then you start numbering your lower order digits from the lowest value. So there's only one lower order digits here, the ones digits. So if you want to get a number that's higher than this number, we're going to increase this by 1. And increasing 0 by 1 is going to just give you 1 in decimal. So it becomes 1, and then every other lower order digits will start its numbering again. So it will start again, and then if you start again, it's 0. So it becomes 1, 0. And we call this the number 10 in our everyday interactions. If you want to go above this, you add 1 to this. It's more or less like you started counting again from here. You increase the magnitude, so you get the number 11. So let's look at the last possible number that we have that we can use with our tens value being 1. So if you look at the number 19, if you want to increase it, like I said, you look at the digits and you look at the highest possible digit. That's not a zero. There's a zero here, but it's not really necessary. You look at this number here and this number here. If you want to go above it, you have to increase the higher order digits. And you can increase this one because after one, there's a number two. And the number two falls within our allowable digits for our decimal number system. So this becomes 2. And all the lower order digits return to their smallest value, that's 0. Here. So let's look at some other number systems. We are going to look at a number system, the binary number system. We are going to apply the same knowledge we have from what we just looked at. So before I go on, let's go back and look at the number system, the decimal number system. Now, in decimal, we know that there are 10 possible numbers, and what you have to know here is that the prefix deci means 10. In the binary number system, the prefix bi means 2 or 2. So what this means is that our binary number system has only 2 possible digits to represent its numbers. Just like the decimal number system has only 10 possible digits to represent its numbers. And those possible digits are 0 and 1. So if you want the number 0 in binary, it's just the 0. Number 1 is just the 1. And if you want the number 2, from what we've learned, this number 1 here is the highest possible digits in binary. And if you want to increase it to the next one, that's the number 2. What we have to do is look at the next place value. In this case, that's a tens value. And what we have to do to the tens value is increase it by 1. And then all the lower order digits, they'll start from their primary value of 0. So if we want to get our number 2, what we have to do is to increase this. So this becomes 1, and then this will start its counting again. So it becomes 0. So in binary, the number 2 is 1, 0 in base 2. If you want to get the number 3, we'll increase the lower order digits by 1. So this is number 3. It becomes 1, 1 in binary. If you want to get number 4, we try to increase the lower order digits, but we can't do that since 1 is the highest possible digits in binary. Then we move to the tens. Can we increase this one? We can't increase it. But we know that there's a 0 here, the 100th position of this number. So we're going to increase that one by 1. So if we increase that one by 1, all the lower order digits will start again from 0. So it becomes 0, 0. What about 5? So if we want to increase it to 5, we increase the lower order, the smallest lower order digits by 1. So this stays the same, this stays the same, but then this will increase by 1. So that will give us 5. What about 6? Let's try increasing the smallest lower order digits, but we can't because 1 is the highest possible value. So let's try with the next one, the tens digits. So if we try to increase the tens digits, it's possible since there's 0 is not the highest possible value. So this one will be maintained since we didn't touch it, but this one will increase to 1. And when this one increases to 1, any other number that's after it, any other digit that is less significant than it, in a sense, will start again from 0. So it becomes 1, 1, 0. And if we want to get our binary number 7, we're going to try to increase the lowest possible value here by 1. Can we do that? Yes, we can. So in 7, it becomes 1, 1, 1 in binary. So let's look at the binary number 8. Can we increase this? We can't. Can we increase this? We can't. Can we increase this? We can't. But then there's a 0 here. Can we increase this? We can. So after increasing this, all the other numbers after it will turn to a zero. So in 8, that's 1, 0, 0, 0. And that's the binary number 8. So far, we've looked at the decimal number system and the binary number system. And there are two other number systems that are mostly used. We have the octal number system and then the hexadecimal number system. The hexadecimal. Yeah. So binary, like I said, has 2 digits because bi means 2. Decimal has 10 digits because deci means 10. And octal has 8 digits because octal means 8. Now hexadecimal has 16 because hexa means 6 and deci means 10. So it becomes 16. All the number systems follow the same rule of thumb. But when you get to the number systems that are of a higher order than the decimal number system or the number system in base 10, you have to introduce letters. So let me start with base 11. Base 11 has all the digits in base 10. Just that you have to add a special character that we are all familiar with, the letter A. So this becomes the 11th digit in base 11. And base 16, the hexadecimal number system, has 16 digits. So we are going to add 6 digits to the decimal number system. So that becomes this. So these are the possible digits in the hexadecimal number system. That will be all for today's video. Thank you very much for watching, and I'll see you in the next one. Have a lovely day.